All right, Master Mason, note you marshmallows. Get up and get ready. This is some Tom Cruise, John Wick, fucking Mission Impossible, Edge of Tomorrow shit we're doing right here. All right, so he's into everything. Scientology, you know, eventually he's on the Among Us spacecraft. We throw him into the volcano and come back. It'll be all right. It's Scientology, Tom Cruise. All right, but at any rate, here on the earthquake generating machine that is Earth, we are working this new tutorial manual. You got some override, x-axis caliber. I mean, all of this will be essentially somewhat essential. Let's see what the setup screen. All right, so we got some setup screen, x-axis calibration. These are probably in millimeters. X feet per minute. So those are going to be my feed speeds. The distance, inches. This might be a full one where you have to program all the limits in. Generally, I like to make my marks. I imagine either it's going to have manual brakes or sensor brakes where you got to program them in, or make the limits, push the saw over there, change your limits on the saw. Depending on which one that goes, one of them being G code, one of them being M code against saws in general, or the size and shape. Again, so as I was telling you here, some of this material will be useful while dealing with some of the programming, profiling, octagonal cuts. You know, you want to change some of the angles on the machine. You know, of course, resetting those things, honing the machine is the biggest bit of that. Now, a lot of this is being critical and very important. I imagine that they're not going to start me off with some of those big baddies right off of the bat. A lot of treads and patterns. Figure out how to line up your edges, straighten everything off, get the fundamentals down, because those fundamentals, while profiling or running octagonal cuts, will be your base mechanics. Always start off of those steps, and that'll go over here, because essentially they're the service parts. How do I know this for a fact? Because any one of those pictures you'll see in there are essentially a fine description of this little marshmallow right here. Okay, this is specifically general relativity. I've copied this out of a general relativity math book, and special relativity was the combining of those two features. That if you would have to track a lot of this material for a mathematician's degree, but in the stone mill, basically what I want you to look at is, we call them the marshmallows. You're a marshmallow, because I can't tell you whether that's the incident that you're in, or if we're just talking about who the fuck you are in general relativity. I got to make a line for this. I got to make a distance for what y is relative to x. And that could be anything. What's up? What's up squared in the next motion of you burning rock? I mean, when we're going to grade that off, that becomes constant. You did it once, it worked great 100% of the time. That one time you didn't do it like that, whether it be because the rock was wrong, or because of the rock was wrong, M1, M2, what's center mass inside of here? It was a rock of this shape for something, but you were actually over here and had to compensate for that setup and stuff like that. And then that continuance is going to go through, like you'll be buried in a hurricane under a mountain of rock down here when this thing just takes off on you. And that's about a lot of this abruptly long sequence of reciprocating terms. Thermal rock, Park Industry, Jaguar's operations and maintenance manual. Well, that's not necessarily operations. I mean, if you want an operation book, I would take my field manual out, my little mass gap here, and I'd say, well, basically how to set up one of the saws, or how to set up my station, you know, and then start your limit, set your brakes, height, feeds and speeds, and then cut coefficients. Like, this process takes 5 minutes. These hits if I'm running stacks. Then the stacks go like that. We're compensating sort back time, and we're compensating for cut coefficients and things like that. And then you can make those cut coefficients. Jared did a bunch of them for the blocks, and I used to do them for the table saws like this. They'll chop up all the blocks. I'll tell you what the grade was out of that, the total numbers of cuts. It's totally trackable and easy to do that. And again, this is something that when you look at MSHA or OSHA for the ground game at a place like Gustin's, where it's all just throwing stuff in, and they give you the triangle of stability about the skid steers and distance away from the forks problem. Well, this is the same problem. and you have to integrate that new cut coefficient. How much time are you doing this? If I'm going to bolt something to or weld something to this station, like a cut coefficient, then the numbers have to be mechanically sound like a fork break in at that distance because of those weights, and that's that action at a spooky distance. That's calculus. That's a wave function. I'm just saying -1 over here to 0 starts me at x, and if I go in a direction, it'll look like this. Now, to program that on a scientific calculator or on one of these, it requires a lot of that ground operation. How to thermal rock, how to stack a pallet, how to, compensate for that read and order. Well, they become combatives under the heading of what this is. West Point, or the 5 bureaus of the Navy, Army, Air Force, Marines, and Space Force, or bluestone militia, right? Because that's essentially what that is. It's a militia. Any 82 against it scored an 83, I guess, by the standard of general relativity, says even in the own army, you have a militia. You have a private subset that is not the correct answer, but what we do is teaching the right answer exposes those one functions away from the real military. All right, so that's the machine. That's why they call the Marines the machine shop. You're in there learning your psychology, you're doing those things, and essentially, I'm as much a part of this machine's biometrics. The Sarctic, GOC's Sarctic Church of the Broken God. I'm the biometric squishy approximations of that. Now, we can generalize that to say the Tomb of the Unknown Mason, or any Mason in the future, once these numbers are science. Those Epson spheres can compensate. I'll balance the equation. I'll say he's doing another task, or he's not as skilled in this time frame. And that makes physics a lot more appropriate, because then I could say, off of tasks A, guy X here to your Y, being a second order operation to this relative mass, we could say that that's that saw. So I don't want to just leave you hanging. I actually want to show you what some of this stuff looks like in an actual field tutorial. And again, what that'll look like are these 5-foot saw programs. It's gonna come in here, stop motion off, hit the switch, blade up and forward. You always want to make that far and away in the far corners your home position to start at the front of the saw. Check your limits. Make sure your top and bottom limits are where they're supposed to be inside of this heading. We're going to start that over. We'll check the limits when we set the block, and then these are for Delaware Basin, but they'd work the same way here. X is X. If the program was a little different, we're calling that the NP problem. It's the organizations of field theory. Well, maybe stop motion isn't the first action, or blade up would be the first action, but basically in that small triangulation, it's going to be that way. Load block, size, and shapes. This is the second step of programming the saw. All of this right here don't get you fuck nowheres if you can't get rock to the table. It's a whole part of the process in the biometrics M code to G code of this being an actual CNC machine or government, right? Because essentially on here, we're going to talk about points and dimensions on here. Is this a 36 million dimension object? No, they're one dimensions, but this dimension A can start the Schrodinger's equation. It could say that is the Hubble's constant from right now that's red shifting everything else away. That's the bunny. And that's a race war against any culture, a bird that has to do bunnies for seeds and they're move to an area or do migrations and crazy shit that they do. And that's a dimension of humanity. It's a dimension of this situation in that box, but really it's just XYZ because they're not really one dimension. It's X dimension. X dimension is Y dimension, and X and Y dimension are one dimension that correlates the end of that limit or that series, but it is far from the end of physics. General relativity didn't solve all the world's problems when it came out, guys. You still have to learn that, but we knew that problem, and then I tested about how much you know about general relativity. It's in the saws around you. I'm trying to make that integral. We'll be speaking the same language. I'll know how out you are on some things if it was my saw, because physics, basically I'm looking for 83, an irrational number in you, not 83 for your skills working that saw as a master mason. You understand me? I want you to be better at tracking the irrational numbers, because for me, thermaling bluestone up there is as critical. Why? Because I know I've done the job. I've had to do the thermaling for a Sawyer on these, for multiple Sawyers on this side of it. You start to offset the time ratio to how many people ratios, and that's going to tell you which program you should take, your timelines, the approximated value of a thing, the adjusted number of situations. It's going to give you chemical analysis reports of the company for the overall mass gap. And in itself, I mean, we look at this looks like a monster. And the real mass gap for all the mechanics ones is this is just part of it. This is really the mechanics one they need. They need the parts, they need the computer numbers so they can go look them up on the internet if something breaks. But for the most part, you as a limited operator, as you're working your journey through this, and what's north on Saron's Middle Earth here, is to kind of look at this and say, eventually I'm going to do those. But most of the stuff, it might be a blade operational change, which might come into 1 or 2 pages inside of here, and you want to know that the bolts are correct, that the kerf, some number inside of there, but most of that's going to be trained to you in here. You might be, if you recognize that point in calculus and what those terms are called there and using this, you could say, all right, later on I'll know where to check in the book. But realistically, they're going to work you on a program. This is that new one. Study this, go home. I'll show you how to do this. Make that connection in your head and bring that in there tomorrow. Videotape it when they learn you the first time, because you're going to want to know how to get back to the home screen, F2 it, change your feeds and speeds and your limits and things like that. So it doesn't seem like those are hard operations. Oh, it's just one button. But by the end of the day, or the first 15 minutes they showed you, you're going to remember the first button maybe, or the last button. And if you're lucky, maybe a couple of things in the middle. But if you don't know the third step to the fourth step of programming the limits of these saws right here, when it actually comes time to touch in the buttons, or actually comes time to load in the block, or you've just finished loading the block into the next process so that blade moves, you're setting this as it's going to line them up. And the edges can work in multiple blocks on smaller functions as well, universally. So that's my big note on this. And like I said, this is this saw tutorial. It's not just the saw, guys. Okay, go big. I look at this, and again, it's really hard for some people to relate. Thermal physician Sawyer to Jordan. These are director of information technology positions in Delhi for the college and the prison in Delhi. I been to both of them. So, you know, visited and had a little stay in one of them, and you start to realize some physics in here, and the workforce function, probation officers, and what systems they need to actually be able to do something. Somebody's like, well, it's just taxation route. You're not going to help me get a fucking job after this. You're not going to help me study or be able to do anything in the company. But meanwhile, you're arresting me in some way. You're slowing down net forces without the real physics, and they become work numbers, the irrational numbers, Hubble constants from your Planck constants numbers, and the adjusted redshift, and all that calculus has to match. And that's really what you can get from just clocking in. Fuck, I don't even need to clock in. That's me. Well, you got it. You might as well use it over there. It's pretty good. I mean, me, I'll figure it out, and we'll do something. But my note for today. Get on that stick, marshmallows. Catch you on the next one.